Hello, everybody. So we're going to work on worksheet for class 5, available on our Canvas page. Scroll down to the module for week 3, go to class 5, scroll down towards the bottom, and there should be a link. You can also find all of our worksheets as well as the answer keys posted after the official end of our class period 540 through the file section under in-class materials. So what we're going to do is, this is going to follow class 4, where I will break you all into groups. I'll pause the recording while you all are working in groups, and then resume the recording when we're all back here to go over the questions together. And if you're looking at worksheet number 5, the first question is actually kind of a review question. It's asking you to comment on kinetic energy, which we talked about on Monday. And so I want to go ahead and start on question 2, 2, 3, and 4. I'd like you to focus on first, and then we will go through those. Then I want just some time to focus on question 5 alone in groups. And then when we're done with that, we can go back and look at question 1 if we have time at the end. Are there any questions or comments folks have before we get started? Any questions about the course in general or anything I can answer? All right, then I'm going to go ahead. There's 8 folks here, so I'm going to break you up into 2 groups of 4. And you should get an invite to join your rooms now. Welcome back. And then I'll go ahead and share my screen. Okay. Can everyone see the worksheet question number? Oh, we should start with question number 2, not question number 3. Okay. Does anyone have an idea of how we might get started setting this up? All right, does anyone know what equation demonstrates the mathematical relationship we're looking at here?
So we just kind of eyeballed it, but I guess we're wrong.
Not necessarily. What do you eyeball?
Well, if it's, you've got 1 and -1 attracting, and then if it just asks how many times greater it is, so then it's just 2.
Okay.
Twice as powerful as the original because of the same distance apart.
All right, let's check. So we're using that electrostatic equation. This is one of the most useful equations that you will use in general chemistry. I can't write over that, I'm just making it worse. Now this is a proportional to symbol, so there is a constant that's missing to actually get a number out, but we can still say something about relative strength, and we can still compare. So if I have E electric, and in my first situation, I have +2 times -2, and I divide by D, and I'm comparing this to +1 times -1 divided by D. This, what's +2 times -2?
-4.
-4 over D versus -1 over D. So now how many times greater is it to have two charges?
It's 4 times greater.
4 times greater. So your eyeballing was correct. Each charge is 2 times greater in the first scenario than the second scenario. But because we multiply here, that 2 times is multiplied by another 2 times, and it comes out to be a total of 4 times greater.
So basically, because each charge has the double, we have to multiply them together. Okay, that makes sense.
Yep. Awesome.
See, that one makes sense. The next one is where we just spent the last 20 minutes trying to figure out
Right.
Bad News Bears.
Mouse. There we go. All right. So here we go. So we have 3 wavelengths for 3 different portions of the electromagnetic spectrum, and we are asked to convert from wavelength to frequency. Okay, so how about here? Does anyone have an idea of what our governing equation will be that tells us what relates to what?
We did see, so the speed of light.
Mm-hmm.
The 3 times 10 to the 8th meters per second.
Okay. That is a constant. Can you use that constant for anything?
Well, after we converted all of the frequencies into, well, we converted them all into centimeters and then later into meters. But so we converted them all into meters and then added them together. So after that, it's just you divide your C by whatever your total thingies are.
So I think I'm hearing from you.
Is the
C equals lambda nu, wavelength times frequency.
lambda?
Is that correct?
That's the one. Yes.
Yeah. So we can actually rearrange this for the purposes of this equation and say that, so all I did was I moved this lambda over and then rewrote it backwards so that what I'm solving for is on my left side.
Mm-hmm.
So frequency is equal to speed of light divided by wavelength. As you mentioned, speed of light has units of meters per second, which means since I want to get out units per second, all we need to do, as you said, is divide by a meter. Something with units of meter, not literally 1 meter. So let's start here. So let's say frequency of our X-ray is equal to 3.00 times 10 to the 8th meters per second. Our wavelength is 1.00 angstroms. And now we need to convert angstroms to meters.
Times.
So Chris, do you mind if I pick on you?
Yeah, I'm not sure how much help I'm going to be, though.
Oh, remember when you asked me what the symbol was?
For the A?
Yeah.
Yeah.
Where did I direct you?
You directed me to the top of page 2 where it says 1 astrom, is that what it's called, is equal to 10 to the -7 or -10 meter.
Exactly. So that's right here. So that means 1 angstrom is 10 to the -10 meters. Scroll back down. Whee. Okay, don't need that anymore. And now if we look, meter cancels out with meter, angstrom cancels out with angstrom, and all we're left is seconds on the bottom per seconds. So we can go ahead and solve now. So if we take 3 times 10 to the 8th and divide by 1 and then divide by 10 to the -10, we will get anyone? So you can plug this into your calculator, but you can also just use exponent rules. So 1 over x to a -10 is equal to, actually, I don't want x. Well, yeah, let's simplify this even more. 1 is equal to just 1 to the positive 10. So all I'm doing is flipping that up to positive, and then a positive exponent times another positive exponent, just have to add them together. All right, what are your questions?
Wait, are you saying that's the answer?
That's the answer.
Wait, what? So we just ignored the 473 nanometers?
Well, we haven't done that one yet. So we need to do this for each of these.
Oh.
Yeah.
Okay, that makes sense then.
So
Okay,
for
so
the
what's the
I'm sorry.
frequency for each source?
Oh, gotcha.
Yeah, we added them all together.
Ah, no.
Well,
so
that explains why we were way off. Okay, cool.
we tried to do each one.
Mhm.
So for that, did you just round it to 3? Because for some reason my calculations got like 2.998.
Oh, yes, that's because you used 2.998 times 10 to the 8th meters per second for the speed of light. Is that correct?
Yeah, I used that, then I divided it after I.
Yeah.
So that one worked too if I did it that way? Or did I sound like
Actually,
completely off?
because I gave you 1.00 angstroms, your final answer does need to be constrained to 3 sig figs. So 2.998 will round to 3.00.
Oh, that makes sense. As soon as you significant. Okay.
So your math was totally fine, totally correct. It's just a question of sig figs.
Got it. Okay, that makes sense.
No, your favorite friend, right?
Oh yeah.
Okay, so now let's take on the radio. So frequency of our radio station. Oops, I just tried to write station. Silly radio. Okay, so we start with 325. Oh, no. Confusing myself. Start with the speed of light times 10 to the 8th meters per second. Our wavelength is 325 centimeters. And can anyone tell me off the top of their head what our conversion from centimeters to meters is?
Wouldn't that be 3.25?
Nope, it's 325. There's no decimal in there.
Oh, I'm thinking about with the exponent. My bad. Yeah.
Oh, scientific notation. Yes, 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 yes. Although, there's something else you might have done, Chris.
Oh, what's that?
You might have converted in your head to meters.
That could have been it. Yeah, like I said, this question was kind of up in the air for me.
So our conversion centimeters to meters, centi is 100, so 100 centimeters to 1 meter. Or as Alex likes to do it, for some reason that is beyond me, 1 times 10 to the minus second meters is 1 centimeter. So now we can plug this into our calculator. Oops, got rid of my exponent. 9.23 times 10 to the 7th inverse seconds. Questions on this one?
Surprisingly, that's actually the number I got in the way I did it.
Woo!
Except for some reason when I did it, like I was telling you earlier, my exponent was negative instead of positive. So I'm kind of curious what I did, because so far my numbers have been lining up except for the exponents.
You keep getting the negative exponent?
Yeah. Wonder what I'm doing wrong.
Your setup is the same as my setup, or are you taking wavelength and dividing by speed of light?
So I've been doing the dividing. How I did it was I took the 299792458, And then after I converted the numbers, I came out with point something. I don't know what it was. I divided those two, and then I addressed the sig fig so they were the right amount. Although for some reason my sig figs came out to negative, which is interesting. I don't know. I have to look back at my work here.
Okay. All right, and then I'm going to pick on someone who hasn't spoken very much. Enzo, are you willing and able to speak?
Who, me?
Yeah. Would you mind leading us through? I'll write down, but would you mind just leading us through how to do this last one for the blue sky?
All right, so I set it up with the f for the frequency is equal to the speed of light over lambda. So I converted 473 nanometers to meters, and then I divided the speed of light by that.
Right, and how do you convert from nanometers to meters?
I don't remember the conversion factor off the top of my head.
Can you look it up real fast? Do you know where to find it?
Yeah, it's 1 times 10 to the negative 9.
Good. And nanometers are smaller than meters, so we know that negative 9 is 1 times 10 to the negative 9 meters is equal to 1 meter. All right? So,
Yeah.
From what you said, Enzo, this is what I wrote down. Does this match what you meant?
What do you mean?
Does this setup look like what you wanted it to?
Mine looked a little different, but it looks like the numbers are all the same, except I used 299799245 instead of 3.
3. Okay. Okay. Fair enough. Well, then the ultimate check then is, did you get the same answer as I do? For a second. Do you still get 6.34 times 10 to the positive 14 inverse seconds?
Yeah, but the second wasn't under it like that. I think it means the same thing. You just ran out of room, right?
Yeah. Did you say s to the negative 1?
Yeah.
Yeah. Those are equivalent. And yeah. I just ran out of room.
Okay. Yeah, that's what I got. Oh, wait, no. I got 6.35.
Oh, okay.
Oh, I see what I did. I put 4.72 times 10 to the negative 7 instead of 4.73 times 10 to the negative 7 when I divided the speed of light by that.
Chris, are you using your calculator to get these values, or were you doing this in your head? Just
I
curious.
used my calculators to get these values, but it was funny. Yeah,
negative. Okay.
again, I got negative. I don't know. Maybe after this, if we have time, I'll walk you through how I did it. See what I'm doing wrong.
Sounds good. Okay, so any questions overall reviewing this whole thing? Question 3.
No, it makes more sense. Thank you.
Okay. Did anyone start to look at question number 4 before I called you all back?
I looked at it. I'm not sure if I got it right though.
Did you give it a funny look or no? I'm joking. Okay.
I looked at it semi-seriously. I came out with like 6.63 times 10 to the negative 34 multiplied by a really large number, 5.99584916 times 10 to the 14. Anyway, my final answer, once it was reduced, was like 3.98 times 10 to the negative 19, which I don't know if is right.
Why don't you walk us through how you got that number?
when I did it, I looked at the formula on page, let me find the page here. Formula equaled like, sorry, there's a lot of pages. Okay, so E photon equals HV
New.
on page 75.
H new.
H what? New?
H new. Yeah.
H new.
This is the Greek letter new.
Yeah, and so that was Planck's constant,
Mhm.
and it said that V equaled the frequency. So what I did is I took the portion given, which was 500 nanometers, which this was the hard part I had to look up because I wasn't sure how to do the conversion on this. Nanometers, and I had to go over to the page, I believe, earlier, where it showed the graph of frequency and wavelength. So knowing that that was 500 nanometers, I then had to look up how to convert nanometers and wavelength to frequency to get that. And then once I got that, V is the frequency, and then H is the Planck's constant. And if you go to the next page where it says worked example, you go down, it says Planck's constant, H equals 6.63 times 10 to the negative 34. So I took those two, I ended up working out that and multiplied it to get my answer.
Okay, so I was trying to keep up with you as you talked. So here's what I have so far written down from your explanation. Is there anything missing?
That looks pretty right. Although I wasn't able to figure out how to convert it from wavelength to frequency. So I had to look up the answer to that.
Okay,
For some reason
okay.
I wasn't able to do that.
No, good question. Okay, so what did we just do in question 3, someone else besides Chris? What was question 3 all focused on?
Solving frequency.
Solving frequency. Okay, question 3. We solved for a frequency from what?
From C over lambda.
Good, from a wavelength.
Oh, so you take the same values you did in there, you just do it here for that.
Well, except here, what are we given as our start? Oh, wait, no, sorry, no exception, no exception. Yes,
Our wavelength.
you use this. So we're gonna, I already have wavelength on the bottom, so I just need to multiply.
Oh, okay, that makes sense.
And unit analysis, okay, nanometers, nanometers, meters, meters, seconds, seconds. And if I do this out, what's left?
Joules.
What? And we're asked to find the energy in joules.
Okay, thank you.
Yeah, that makes sense now. For some reason, my brain couldn't connect how to put the frequency or wavelength into frequency when I was looking at that.
So I'm just gonna use this opportunity to make a plug, especially for those who are watching this video at home. All of Gen Chem builds on itself. So if you are ever feeling lost, this is not to say, especially as we get further in Gen Chem quarters 2 and 3, that it will be immediately obvious or easy. But if you're ever feeling like it feels like something's missing, try reviewing material from a little bit before. Later, again, it might be some larger jumps back. But a lot of things tie into each other and a lot of things will come back. So in this case, literally question 3 to question 4, which, you know, may have been on purpose. But yeah, just that's my plug. Please do not just forget things. Don't cram and then forget. I know that's something that I would do as a student, and it did not serve me well in Gen Chem. So keep an eye on that. And does anyone have a calculator? Has anyone plugged this in, these numbers in?
I got 3.75 e to the 12, 10 to the 12.
Okay. And then Chris, earlier you said you got 3.98. So those look similar, but you said you got 10 to something else, right?
I got 10 to the negative 19.
Oh
But
boy, okay. Anybody else? Anybody
Again,
else?
my negative 19 probably should have been positive if we're following the trend too.
I'm gonna redo it again. Hold on.
Okay. Yeah.
Oh, I know what I did. I did 10 to the negative third instead of 10 to the negative 34th. There we go.
Ah, okay. So now what do you get?
Hold on, I didn't finish it. I just looked at my.
Okay, no worries.
Yeah, I got 3.98 times 10 to the negative 19.
Okay. And now another skill that is wonderful to have, regardless of what field of study you go into, is being able to look at your work and determine whether or not an answer looks reasonable. So comparing with someone else, so the fact that you both got the same number, that's promising, right? It says you probably didn't screw anything up. But we have this times 10 to a negative 19. And what we can actually do is we can check if that seems reasonable. So let's look at only our powers. And then this is equivalent to 5 times 10 to the second. So that's 10 to the second. So that means I have 10 to the negative 34th times 10 to the 8th divided by 10 to the 2 times 10 to the negative 9. All right, again, so let's first, we'll add these two denominators together and the numerators together. So 10 to the negative 34 times 10 to the positive 8 is 10 to the negative 34 plus 8, which is only negative 26. So 10 to the negative 26. And then we're going to divide by 10 to the negative 7. Anybody have a question so far? That jumps okay in size? All right. And now, again, 1 over 10 to the negative x is equal to just 10 to the positive x. So I'm essentially going to flip this up. I did not give myself enough space. Never give myself enough space. So this is equivalent to 10 to the negative 26 times 10 to the positive 7. And now I'm going to add positive 7 to a negative 26. And we're going to get 10 to the negative 19. Now, depending on what your actual values are, so like 6 times 3 is 18. 18 is greater than 10, so that would bump it up to 10 to the positive, or to the negative 18th. But then I divide by 5, which gets me back down to something lower than 10. The point I'm trying to get at is this is rough. If your answer is within plus or minus 1 of sort of that 10 to the negative power, that's a really good like confidence boost that you probably did it correctly. So in this case, I think your answers of 3.98 times 10 to the negative 19 joules looks really good because your power matches what we expect just by looking at the powers without paying any attention to the numbers. Does that make sense? Any questions?
Yeah, that makes sense to me. It's kind of like looking at what value you're trying to cancel out.
Yeah, it's ultimately, it's essentially a quick and dirty oversimplification of the calculation. You pretend that all your numerical values, once they're in scientific notation, you pretend they're all ones, and then you just do the math on the exponents. And then your final answer should have, again, in the neighborhood, kind of plus or minus 1. There is wiggle room because your numbers aren't always 1, but if it's in the same general around that number, that's a really good sign. On the other hand, if you get something like 3 times 10 to the positive 12, right, and then you go, wait, I was expecting negative 19, then you go back and check your work. All right. And by the way, this does match what's on my answer key. I suppose I had some.
Ooh, I got one.
Yeah. All right, and it is almost 5 o'clock. So ideally we would be wrapping up now, but I really want to look at question 5. So let's go ahead and just look at question 5 together. Did anyone happen to start looking at question 5 already? Okay, cool. All right, so this goes into the photoelectric effect. And now I promise no judgments whatsoever. I just want to know for me as I'm talking to you, so what level to talk at. Who watched the video on the photoelectric effect?
Oh, I didn't get to that part.
Okay. You know what then? I think I'm not going to do this one with you all then, because the photoelectric effect is really challenging, I think, to wrap your head around. Like much of quantum, the first time you see something, it's like, what the heck? So I really want this problem to be an opportunity for you to really check your understanding, to go through, see how much you can answer, where you get stuck. So I'm going to stop here, watch that video on the photoelectric effect, read the book, feel free to look up other resources, especially if you're still feeling confused, and then come to this problem, give it a shot, and then as you work on this problem, if and when you feel stuck or confused, write down the questions you have. And if you're feeling up to it, you can actually post that to the discussion board to see if other folks can answer. Otherwise, you're, of course, welcome to message me, contact me. And of course, for the rest of this week, since this is our last official time together, you are also totally welcome to contact the TLC tutors for one-on-one appointments.
Wait, is that covered on Alex?
The photoelectric effect?
Yeah.
Let me double check. So first I'm gonna pause the recording. Alex does not cover photoelectric effect. So this is something that you will not get the benefit of Alex to help you review on. And I have not yet written the quiz for this week, but I intend to write a photoelectric effect question. All my exams in the past have had a photoelectric effect question. This is something that might come up multiple times in your end of week quizzes, especially when it comes to the review portion. So this is something that is definitely worth taking the time, seeing TLC tutor, so on and so forth, to make sure you really feel comfortable with it.
Okay, thank you.
Yeah. All right, now I will stop the recording.